Here's integrated 3. This is problem CL3-123. I'm going to try to do A, B, C, and D. So this first one, I started out by squaring out the quadratic, and if you need to remember how to do that, you can put it in an area model. And so this squared it out, and then I distributed the 3, and then I combined like terms, and then I decided that it's a quadratic, so I wanted everything on the same side of the equal sign. So you can see where I subtracted everything from the right, and then I factored out a 2, and then I decided I would try to factor it. I did actually try to factor it. I could not find two numbers that multiplied to make 54 and added to make -8, so I went ahead and used my quadratic formula. So I had this 2 is just going to go away because it's going to be 2 equals 0, or if that would have factored, whatever that factors out to equals 0. So the 2, it basically just went away. And so now I've just got the 6 as my A and the -8 as my B, and the 9 is my C. And so you can just follow my work here, how I just multiplied it out. I took the I and got it out of the way because this was a negative number here, a -152. 4 times 38 is 152, so that's a little trick. I usually, if it's an even number in the radicand, I'll try dividing it by 4. Because I know 4 is like a perfect square. It's our first perfect square, you know, like 2 times 2 is 4. So it actually did go into it, so I took the 4 out. Square root of 4 is 2. So that's how you kind of like reduce those. And then I see I had an 8, a 2, and a 12. I can divide those all. Like, I didn't show that I factored it, but it's like if you factor out a 2, then you can cancel them all down. So basically they're all divided by 2 now, and that's the answer, and that's the same answer in the answer book. So that was letter A. Letter B, it's got a square root on it, so I want to isolate that square root and then square both sides. If you try to square both sides without isolating the square root, you're going to come up with a big mess. So just get that by itself first, and then when you square it, it'll square out clean. So I added x to both sides. Now when I square it out, that squares out nice and clean. It's like they undo each other, and it's okay. I've got this squared. I can square that out. I put it I didn't even put it in the area model box. I know that x minus 3 times x minus 3 ends up being x squared minus 6x plus x. You could multiply that out in an area model if you need to. And then I decided to get everything on the right hand side so that I could see if maybe I can factor it. So I subtracted everything from the left hand side, brought it over to the right hand side, and I have a quadratic now that I can try to factor. I wanted something that multiplied to make 8 and add to make -9, so I got these two numbers here. So these are my two answers, and then it's a square root problem, so I have to check it in the original. The original is this one up here, so I just recopied it down here with the 1 plugged in, and I got 1 equals -3. That's not true, so that's extraneous. And then when I plugged in the 8 into the original equation, I worked it all out, and I got -3 equals -3. That is true. So the only solution is x equals 8. The other solution that we got is extraneous. Next problem is this fraction-y one. And so I'm going to clear the fractions by multiplying through by 4. So if I multiply this first fraction by 4, it'll be like 12 over 4. It's just going to be a plain old 3. And if I multiply the second fraction by 4, that would be like 20 over 4. That's just 5. And if I multiply the last fraction by 4, that's 4 times a half. That's 2. So now I decided I was going to move everything to the left-hand side to get myself a quadratic that I could try to factor. and it actually does factor. I put it in the area model, and you can see how I got it to factor. And then I use a zero product property. So I subtracted 1 from both sides, and I divide it by 3, and I got negative 1/3. And then on this one, x minus 2 equals 0, so x must equal 2. And those, I'll be honest, I did not plug them in because I don't have a absolute value or a square root. But those are both of those solutions work. And then let's get the very last one. This one, I didn't really see any other thing to do besides just multiply them out and then hope for maybe a quadratic that I could factor. So I distributed the 4x, and I ended up with 4x squared minus 8x on the left-hand side. This, I put it in an area model just to like FOIL it out or to multiply it out. And then I decided, I saw that there's a 4x squared on both sides of the equation, so I kind of just canceled them out because like if I minus 4x on both, 4x squared on both sides, they just kind of go away. And then I decided to take this negative 4x over to the left-hand side, so I added 4x on both sides, and I got negative 4x equals negative 3, and then I just divided both sides by negative 4, and then the answer is x equals 3/4. And that is all.